This one.
Yep. Okay, now apply. Okay. So wait, format, output method, go for Verilog.
Which one is?
Yes,
Which
Verilog
one?
you should have. Yes. Apply.
Okay.
Okay.
Apply.
Okay.
Okay.
Then reopen your waveform file. Close the existing one. Open it. Reopen it.
Open new one.
No, just open your open it. Yeah.
Okay.
Okay. Yeah. Just try to simulate it.
Oh. Jadi masa tu dia sekejap je.
Try to close quarters, open quarters, compile again. Then let's see what happened. Alright, let me know. Text me again.
Okay, sir.
Alright, thank you, Ahmad Nazrin. Okay, let's go to another one. Chan Tian Tian.
Yes, sir.
Yeah, can you present what you have
Yeah.
done? Right.
Yeah. My one can run lah.
Okay.
Okay lah, everything.
You don't have to create a new one. If you have, just open the existing one. Okay, alright. It'll make your life easier, right? Because you've already inserted the value.
But for the output, do I need to run again, sir?
Yeah, for the output you have to run it again unless you save it somewhere.
This what I check. Oh.
Okay. Which one? Okay, this is your output result.
Yeah.
All right.
The question I want to ask, right, sir?
Yeah.
This one, whenever the clock trigger, it will have output for this. But I'm not sure why this one not trigger also have output continue like here.
Which one? You mean on the second clock?
After the second one, coming into the third one. This one.
Okay, coming. Okay, that one. So okay. All right. Let's see. So your mem access address, you change it. Then the output is coming where? So the output coming after the at the positive trigger. All right. So if you want to understand this better, you have to look at your code, right?
Okay.
All right. So okay, sorry. Open your output waveform again. Okay, let's see here, right? So during the second clock, so what happened is that you are having this the same memory access address, right? So then your mem read is high, and then your mem write is also high. Yeah, this is kind of confusing, Tian Tian.
Mm.
All right, so I mean, like, if you want to see clearly how your result behave, right? So you have to give correct input, right? So
So
what?
the mem read and mem write and will have to change to like high low something like that.
Yeah, you cannot have mem read and also mem write both high at the same time, right?
Oh,
Yeah, because it can do one thing at a time. So either it is reading or it is writing. So when you want it to read, so your mem write has to be low.
oh, okay, okay.
Yeah, so vice versa. So if you want your to write, then your mem write has enable has to be high, then your mem read has to be low.
Mm,
Okay,
understand, sir.
all right. So okay, for the other student too, right? So this is how you do your simulation, right? So guys, I mean, like, somebody asked me, right, which part you have to change if you want to, have a different outputs. Okay, listen here, right? So there are two part here, right? So the first one is coding part, and then the second one is the simulation part, right? So for the simulation part, it is depending on your code, right? So the limitation is your code. You cannot simulate something that is beyond your code, right? So you can change the value whatsoever, but all the value will be changes depending on your coding, right? So if you want to change something beyond, for example, like you want to change it, let's say you want to make all the data to be 32 bits, right? So you cannot change it in the simulation. So if you want to change your data to be size for 32 bit, then you have to change it in coding, right? So these
Mm.
are the two things that you guys have to take note. All right, thank you, Tenten. You can try to fix your simulation.
Now?
No, no, later. All right,
Okay,
thank you.
okay. Thank you, sir.
All right, okay. Let's see. Who else? Okay, Alia Husna. Last time you are not ready, so let's see what you have now. Quick, just call her name when she left the meeting. Okay, that's fine. Okay, who else? Chu Yanki.
Yes, doctor.
All right, you want to present your screen?
Okay. Can you see my screen?
Yes. Just go ahead, show your output waveform.
This is what I do.
Okay. Try to simulate it. Oh, it's taking so long. Okay, all right. Now you got the result. Okay.
But at the hold on.
Okay.
This one is consider memory address location 0, is it?
Zoom in a bit. Okay, yes. Okay. Yep, correct.
But at here, the output there will have the value. Yeah.
Okay. You have the value 277. Okay, go back at the beginning. Okay, why is that happen? Okay, remember Chuyanki, right? So look at the look at the coding, right? So if you remember, for the address, right? For the address, what happened is that we skip the LSB, right? So we skip the LSB. LSB means that the least significant bits, which means the bit that is sitting at the most right, right? So if you look in binary, right? So if you look binary, we will neglect the LSB. So when we neglect the LSB, so this one, the first one 000, and also 0001 will be the same. You got it?
Oh, okay.
All right. So that's why what happened is that on at 0001 is actually you are writing value 2727 to address location 000.
Oh, so I no need to start from 000. Straight
Yes,
away
correct.
start
Yeah.
from 0001.
Yep. Yes.
Oh, okay.
Sir,
Right.
sir,
Yes.
for 0002 and 0003 will share the same data, is it?
Yeah. I mean, you have to look in your binary, right? Okay. Wait. Let me share my screen. Okay. Thank you, Yiki.
Okay.
If you have any other question, do you have any other question?
No, this one
Okay.
only.
All right. Okay. Let me answer you guys question. Let me share my screen. Right. You guys can see my screen, right? You can see my screen, guys.
Yes, sir.
Okay. All right. Yeah. I need some response. All right. Thank you for the response. Yes. Open. Okay, all right. So the question, right? So you remember, right? I'm talking about the LSB, right? So the LSB stands for least significant bit. So if you have 0, oh, this is worse. Wait, I'm using a new mouse, right? So let's cancel this. 0, 0, 0. Oh, it's even terrible. But it's okay. I think you guys can still understand it, right? So this one is the LSB, least significant bit. Right, so 0, 0, 1, 0, 1, 0. All right, so that's why if you look into the code, right? Wait, open quarters, right? Okay, if you guys look in the code, uh, okay, this part here, right? So this part here is what happened is that, say, you see, you are taking bit 1 until bit 8, right? So you are neglecting bit 0. So bit 0 is your LSB, right? So that's why here they are just looking in this part, right? So if you do the binary, right? So if you do the binary 0, 1, 1, right? So these two are the same, right? Same goes as 1, 0, 0, 1, 0, 1, 1, 1, 0, and these two are the same, right? Because you are neglecting the LSB, right? Can you guys follow me? Okay, that's great. All right. So I like this kind of session. You guys can ask question. So I'll try to explain it, which is I think will help you guys to understand better. All right. Okay.
Sir,
Yeah.
for the just now question, just now we take a look on the LSB, right? But
Yeah.
since they have a same position, but how about the priority of the data?
What? Okay, how about the priority of the data?
Since
Okay,
just now example, right? The
okay,
011 and the 100 are the same.
okay,
So who will be the first in one? Since we
okay.
using the first in first out, right?
Yeah, I mean, yeah, that's right. Okay, yeah, it's like this. So whichever the latest one, it will override. All right, so that's why. Okay, let's see here. Okay, let's say first you write to zero location 000. You write number 3, right? Okay, this is the first one at the clock cycle, the first clock cycle. This is your clock cycle. All right, so at the first clock cycle here, let's say you write to location 000. All right, so you write memory value 3, right? So this is your data. Oh man, this is terrible. I need to get a bigger mouse. All right, okay, so this is your data. You are writing at location 00, data value 3. All right, then you do like at 001, you write data 4. You do that at location at second clock cycle, right? So 001, you write data 4. So what happened is that this data here will override this data, right? So this is your location, right? So in your memory, these two are referring to the same location, right? So first you store 3, and then at the second clock cycle, it will erase 3, and then it will insert 4, right? So it's depend on who's the latest one writing to that location, right? Is that answering your question?
Yes, yes, sir.
Okay, all right, okay, that's
So,
good.
but sir, also if
Yeah,
we don't want to override it, we want to save it in another slot. So how we do it?
okay, if you don't want to override, don't write to this address again, so you have to skip, right? So you have to skip. That's why I mean, like, it's good to write your address in binary so that you can see it. So focus on your I mean, like, just neglect your LSB, right? So let's say you want to write at the different location, right? So let's say we do the binary, right? So 001, sorry, 000 001. Okay, wait. Let's make it bigger lah. I'm using a smaller mouse right now. So 000 001 010 011, right? So you focus on this part, these two part, right? So you neglect this part. So you I mean, if you see, so you can write here, and then you can write at the what do you call it, at the third location, right? So the idea is you just keep on skipping one, right? So let's say this one in decimal is 0, this one is 1, 2, 3, 4, right? So you keep on skipping one, so you write at location 0, 2, 4, right? You got it? That's how we do it.
Okay, sir. So, got another question is if we including from the LSB, right? From we
Okay.
start from 0 to 7 instead of 1 8 to 1. So what will happen?
Okay, you mean in the coding part you want to change, right? You want to
Yes,
change you want to change
start
zero
from zero
zero
to seven.
to, okay, this will solve your issue, so you don't have to skip.
Oh, so like this we will keep it, but yeah, I got changed my code and like this, but
uh,
the data was shift 1 clock to the back right side. So I don't know why it cannot stay in the fixed address.
let's see, can you share your screen, Kim?
Yes, sir. Now do you see the screen?
Yeah, I can see it.
Okay. Now, so at first here, I want to store my 1070 at 001, right? But
Okay.
now it shift to the backside. The second one I set as a 00 here. This is a delay address here. At here 1070 at delay address here, and same as this 1071 here also come to hit this second clock here. Here also same.
Oh, okay. Okay, boy. So I think your problem is the same as who's that? Tian Tian, right? So I think what you need to do is that look at the membrane and membrane, right? So make sure both are not high at the same time.
Okay, sir.
All right. So when you read, then make sure the write is low. When you want to write, then make sure the read is low. Then you can verify the result properly.
Okay, sir. So
Alright.
but I got another when I got try when I do the read low right high right, but I
Okay.
got a zero at the here the output side here.
Which one? Can you give it a try?
Let me try first. Let me
Okay.
try.
All
Okay.
right. Right. You give it a try. Then if you done it, let me know. All right. So meanwhile, let's try to pick somebody else.
Sir,
Yes.
I got another question.
Go ahead.
Okay, can I share my screen first, sir?
Yeah. Go share screen.
Okay, did you saw it?
It's coming. Yeah.
Okay.
I can see it. I can see it now. Yeah. Go ahead.
Okay. So, over here. Hello.
Hello. Yeah. Go ahead.
Yeah. Okay. So I get the like I get the I succeed to read every single address lah.
Okay.
So my question is, why the things will read at over here, not over
Uh huh.
here?
Okay. All right. So remember last time I've told you guys for the right, for the right. So if you look into your code,
Yeah.
go open your code, right? So let's try to understand the code. Okay. So if you guys see on the writing part, so we are using if, right? So and then if you see this if is located within the always, and then there's an @ sign, then post each clock, right? So
Yeah.
what happened is that the writing part
Yeah.
will occurs during the positive cycle, right? So positive age cycle, but then on the reading part, right? So on the reading
Yeah.
part, we are using a sign, right? So when we use a sign, so this is the syntax that is not sensitive to clock, but it is sensitive to the input. So every time you change your what do you call it, your input, then it's gonna update. Okay.
Oh, okay, okay.
All right.
So
Okay. That's why
so
if you look into your output waveform, open your output waveform.
yeah.
So every time you change your input, right? So
Yeah.
it's going to update.
Okay. So even I didn't put any clock cycle, I also will get the output, is it?
Yes, correct. Yeah, because it
Okay, thank
is
you.
not sensitive of the clock.
Okay, thank you.
All right. Okay. Who else? Let's go. Pick a name. Farisha Isley.
Okay, doctor.
Yeah. Share screen.
Okay, so this is my code. Can you see it?
It's coming. Okay, yeah, I can see it now.
Okay, and this is my input for my waveform, but I did a mistake because I put my numeric number at location 000, supposed to be at 001.
Okay.
Okay, and I already simulate it, and here is the output.
Zoom in a bit, yeah. And you can change the radix of your output.
2 hexa.
Yeah, follow the same one when you the memrite. Okay, all right. So yeah, I mean like you do you understand why you got this kind of output, Farisha?
No.
Okay, if you see right, if you see, we the one that I explained just now about the LSB,
Okay.
right? So that's why if you see your output keep on repeating,
Ah,
because remember we are neglecting the LSB for the address.
alright.
All right, so actually you are writing the same thing at both location.
Hmm.
Right, so that's why you but the thing is that you are writing all the same number, is it?
Uh,
No, you keep on increasing by one.
yes.
Okay, all right. Okay, all right, so I think guys, it's good that you guys can simulate. This is, I think, good, but the thing is that you have to really understand the coding, so
Okay.
which part that you need to change if you want to change the coding. Right. So what happened if you tweak this part, right? So for an example, right, if you want to get rid of the LSP, right, open your code, right? So which part you need to change?
LSP here.
Change to what?
So it's just 07.
Okay, all right,
Is it?
yeah, give a try on that and see what happened, right? Okay, thank you, Farisha.
Alright. Thank you, Doctor.
Hello, sir.
Yeah, go ahead.
Yeah. So now this is my result output here.
Okay,
So I set the read as high here, so I can read all the data right until here, and this backside is right.
okay,
But the output is 0 here. It's showing here this line.
okay.
Yeah, it's 0 here. So I don't know why.
Oh, okay, let's see. Memory.
Zoom
Okay,
out beside this.
it's okay. Oh yeah, that's right. That's right. I mean, like, yeah, you didn't set the mem address during the read,
Hmm?
Kim Hui.
Yes.
Yeah. So what happened when you want to read, right? You need to give the address, which address that you want to read from.
Oh, so what
So
base?
okay, like this one, right? The first one. So
Mm-hmm.
what you are doing is that you giving the address. You are telling it which address that you want to write to, right? Which is correct, right? So and
Mm-hmm.
then you give
So
what value you want to write to. Same goes when you want to read it. Right? Go into the
here this.
when you set the no, not there. Uh, show me at which part that you start to read.
I start from here. At first for
No,
this.
I mean you have to write first, right? So you have to write first, then you can read.
Oh, okay. Oh, so I think I
You got it?
okay. This is the right one. I think I terbalik ya.
Yeah,
Okay,
totally. And then the other thing is the address. When you want to read, you have to give address to again.
address.
See, yeah, the address location. You look at your address location. So you just set it on it, make it zoom out, zoom out. Okay, so okay, you see me, yeah, your address location, you just set it at the earlier part, right? And then
Yes.
after that, you just set it as 0.
Yes.
All right. So if you want to read, then you also need to repeat the address again.
Oh, so the front here 14 address I need to copy and paste at the back side.
Yes, correct. Because you have to tell which address location that you want to read from,
Oh, okay.
as they don't know which location that you want to read from.
Okay.
Okay, that's
Okay,
how
sir.
that's how computer works, right? So you when you want to go to address memory location, you have to give the address. Then they know where to go and to pick the data from.
Oh, okay, sir. Thank you.
All right. Thank you, Kim Hoy. Who's next? Gan Kai.
Karena student here,
Yes, sir.
Kim Hoy, can you mute? Kim Hoy, can you mute your mic?
Oh, sorry, sir.
Right. Kai, yeah. Can you share your
Yes, sir.
screen?
I have problem with my quarters, so
What's the problem with your
wait,
quarters? All right.
yeah, it just cannot compile. So can you see my screen?
Yes, I can see.
Yeah, I just cannot compile, and I cannot find the problem because it keep running like this.
Can you scroll up a bit? Your code.
Oh yeah, wait.
Okay. Anybody want to guess what's the problem?
The top level naming is wrong.
Yeah.
Yes.
So your module name, right? So it has to be the same as your project name, because this is
Oh.
your top level module,
Oh, okay.
right? So you just change your module name to lab 222.
Module. How can I change it?
In your code, you see module lab 2, right?
Oh, okay.
Yeah. Why you have, yeah, why you choose this 222? Is that lucky number for you?
No, just click like this.
All right, so try to compile and see. All right. That's the things that we have to know. I mean, like sometimes we have to know how the software works, right? So that's how it works. If you don't follow it, then we're going to get error. All right, let's go and try the simulation. Okay, Kai.
Okay.
All right. Okay, let's pick another student. Left hand. Don't worry. Who else? Harry Tan Heng. Harry. Are you there, Harry? Kai, you can mute your mic.
Oh, sorry.
Right. I cannot skip like that. What's wrong? You're not ready? Yeah. You have to be ready. This is our lab session. Alright, so in the next lab, I'm gonna pick your name first, right? Make sure you're ready. Okay, Ihsan already done. I think Ihsan, you contacted me, right? You got a problem? Is it you or somebody else?
Yeah, it was me, sir.
Yeah, did you solve it?
I haven't reinstalled Quarters 2 yet, but my friend had suggested me for the waveform simulator, for
Okay.
simulation, there is an option button
Okay.
where it asks whether to use modern sim or Quarters 2 simulator.
Oh yes.
So I pick Quarters 2 simulator,
Uh-huh.
and the software can simulate, but I'm not getting the output that I wanted. So I'm just about to troubleshoot that part.
All right. Isan, can you share your screen? Show me how you do that. The setting. I forgot that
Okay,
part.
sir.
I think that part can help a lot. Yeah.
Alright, sir.
Okay. No, Isan, share your screen. I want to see how you change the setting. Hello, Isan.
Yes,
Okay, all
sir.
right. Okay.
Can see you,
I'm
sir.
listening. Yeah. Okay, go ahead, show it.
In the waveform simulator software, I press this tab,
Okay.
simulation tab, and then to options.
Okay.
Then it gives me the two options, Model C and Quarters 2. I pick
Uh,
Quarters 2.
okay, all right. That's great. Okay, guys, for those of you who yes now no Ahmad Nazrin. Ahmad Nazrin, you can try that tweak, right? So see whether it can work. So now have you tried that one, Ahmad Nazrin?
Saya dah try juga sebenarnya.
That one, the solution yang Ihsan tunjuk tu.
Dah.
Does it work?
No.
Okay, alright, it's okay.
Wait. I will try again.
Alright, try and tell me whether it works or not. Alright, so who else? Kanika.
Yes, sir.
Yeah. Can you share your screen, Kanika?
Yes.
Go ahead.
Can you see my screen?
Not yet. Okay, it's coming. Yep, I can see it now. Go ahead, Kanika.
Yes. This is my output.
Which one? This is not your output. This is your coding, Kanika.
Can you see my output?
I cannot see. Are you showing your waveform?
Yes.
No, cannot see. I think you choose to. Just choose to share your screen. It's easier. Yeah, sorry. Yeah, you need to share window, not screen. Not window, screen, right? Yeah, share your screen. Sorry.
Can see?
Yeah. Now can see.
This is my phone.
Can you change the radix? Oh yeah, for the output. All right. So do you understand what's happening?
I don't know why like this. When the 2 and 3 share the same output.
Yeah, I mean like refer to my previous explanation because of the LSB.
Okay, sir. So I should change the
Wait.
coding.
002 and yeah, that's right. Yeah, because we neglect the LSB. So that's why. I mean, it is writing the same number,
Okay.
the same location. It's gonna override, right? So it's gonna take. If you look here, it's gonna take the value that you write the second one. Yeah.
Okay.
All right. Anything else you want to ask, Karika?
No.
All
Thank you, sir.
All right. Thank you. Okay, let's pick one more, then I'm gonna start to explain lab number 3. Okay, let's see who's after Kanika. Kelvin.
Hi, sir.
Hi, Kevin.
My one is same with Tian Tian one, but I haven't read it.
Which one?
My one actually is same with Tian Tian one.
What do you mean same? What did you get?
Wait, I'm running.
All right.
So actually, this one just now I'm using the binary one.
Okay.
This is my last 16 bit of my matrix number lah in
Okay.
binary.
All right.
And I have tried to change the read to become like down up lah.
Okay.
Low high lah.
Uh-huh.
Then still the same result.
I mean, you change the read, but you didn't change the write part, right? So the write part, remember, one at a time. You cannot do both, right? So if you look on the first clock cycle, right? Yeah, the first one you make the read low, then you make it high, right? When your read is high, look at your write. Your write is also high.
Oh, you mean
Okay.
the write enable, is it?
Yeah, write enable, yes.
So when here the read is high, I must put here low lah.
Yes, correct.
But if I put here low, means this one I also didn't change because this in the clock cycle positive it only changed, right?
Okay. By looking at the code, right? Remember, the writing is depending on the clock, right? The writing is depending on the clock, but for the read, it does not depend on the clock because you are using a sign, right? So it's going to update the value depending on the input, right? So the output will be updated all the time depending on the input.
Oh, okay. So here the clock I should put the high in front first.
The clock doesn't matter.
Doesn't matter. Okay.
Okay, all right.
Okay.
Anything else you want to ask, Kevin?
I think I have to try first.
Okay, all right. Okay, guys. So anything you guys want to ask regarding lab 2 before I start into lab 3?
Sir, I got problems.
Okay.
Wait, I present.
Okay, go ahead.
I already see the screen.
Wait. No, cannot see.
Cannot see.
Yep.
Yeah. Okay. So, sir, can you see already?
Yep, can see it right now. Yes.
Okay. This is the waveform, and then once I simulation, it got problem like this. It back to the last time I do the lab 1. He say like this, and I follow this thing. I go back to the analysis and synthesis on the code side, and I got the here EDA netlist writer. I go to edit setting. Also already changed to lab 2 Polka, but it still come out the situation like this. It say lab 1.
Okay, for this kind of situation, right?
Yes.
What you can do is that, the first one is that you can go to, I think go to project.
Go to project.
This is one ways of doing it. Go to, where is it? Wait.
Okay.
Let me set up my this. Okay, wait. Project. There's one part where you can clean, tools.
Or clean the previous one, you mean?
Yeah, I mean like they gonna clean all
Or
the,
this
when,
clean project.
yes, clean project. Yeah, try that one.
Uh-huh.
After you clean project, so all revisions,
Or
because
revision.
when you compile, right, so there are files that they created. Sometimes when the files overlap, they got confused. They keep on referring to the wrong source file. So,
Oh,
but this is one tweak, right? But if this doesn't work, then you have to create a new project. Then just copy all your main file, right? Your .b file, your .bwf file.
okay. I will try.
Okay.
Okay, thanks, sir.
Right.
Hey, sir, one more questions.
Yeah. Go ahead.
This why this the input here in the coding one is different with the others and the lab one like this behind this got comma only, but these others got the full stop and comma one.
Which one?
This the input here after the assign all the input, right? In the
Okay.
coding. Okay, this part.
Okay.
Here the behind one just got the comma and
Okay.
the others got the dots and the comma. Is it just a sign or what?
Oh, okay. Okay, on the top part there, right?
Yes.
So if you see, I mean, you are declaring a module, right? And then when you declare a module, and then you, I mean, like there are many ways of doing it, right? So what the way that we are doing right now, so we are declaring the input and the name, right? And then when you are declaring within this one, this module declaration, you see after module lab to Poca, right? There's an open bracket.
Open bracket, yes.
All right, so everything inside this open bracket, I mean, like after one name, then you have to follow it by comma.
This is the full content here, and this is the
Full,
for the full stop one. Yes.
that's the semicolon.
Okay.
All right, then outside the bracket, then we follow the normal way again. We just use semicolon.
Okay. Thank you, sir.
All right, okay. Don't forget my problem. I already forgot your problem. I don't like problem.
Sir,
Okay, yeah.
I got done my result here.
Okay.
Okay. Okay, now. So now here I said, at first we write the data first, right? So right until here now, start read the data from the just now address here.
Okay.
So but it still got a bit delay here. Maybe it's my address here. They got a 000 here as a delay address here.
This one you run what Kim Ho, you functional or timing?
What? Sorry, sir. Can you repeat again?
Yeah. What kind of simulation did you run? Timing or functional?
Timing.
Go for functional. Timing because
Functional I cannot run it because I don't know what. Let me share my screen first.
Okay. Because timing is important because at first we just want to go with functional because that's the most basic one. Timing, they consider all the routing, the the wiring that they do inside the circuit. All right? So that's why you can see that there's a kind of, you know, hair wire, you know, there's a mixing output, something like that, because of the timing simulation.
Because when I running the functional simulation, it got an error here, so I didn't run for the functional.
Okay.
But I think should be okay for now here.
It's not is yeah, it's not is fine.
Oh, okay. Wait.
Yeah, now it looks better.
Ah, yeah. Oh, okay. Should be okay now.
All right.
Yes. Okay. Okay. Thank you, sir.
Okay. All right. Okay, guys. Any other question before I start and explaining your lab 3?
Sir, I get the same thing after changing the enable.
You got the same thing? Sorry, can you share your screen again?
Here still the same. Only positive clockwise. Only only positive clock edge only hidden to the right data. My output.
Yeah, correct. The writing part only being done during the positive cycle. Oh, sorry,
Oh,
positive
so
age.
the read data only change when the write is changed lah.
Yeah, of course.
Oh, okay,
Of
okay.
course,
Oh,
yeah. When you write, then when of course then there's something changes, right?
oh,
Then
okay.
you read whatever you have written.
Oh, okay, okay. Understood.
All right.
So, sir, from the just now example from the Kelvin, right? So we
Okay.
can read data, then write again, and write data and read again, right? Not instead
Can.
of the read all the data first.
Yeah, can. That one also can. So the idea is that you have to write first, then you can read. All right.
Oh, okay. Okay, thank you, sir.
Guys, what we are doing right now is just the emulation. You know, emulation means that we try to, you know, do just like an example how the memory in the real life is working, but it's not exactly as what we are doing right now, but this is a basic concept, right? So later you're going to go and see how the different way that this you know, memory writing being done, but basically this is how it being done. Because if you look back in your real PC, right, sometimes to read on one location you need multiple clock cycle. So this is what we say bottleneck, you know, this is what we say as bottleneck. You know, when you using a laptop or your PC, right? And then you are using your normal hard disk, which is using the this one, HDD, right? And then you compare it with the one that using SSD. No, I'm not sharing anything. I'm just explaining. Alright, because I don't have any slide prepared. I'm just trying to explain to make to mean, get you guys make sense of what happening. Right. So the SSD and HDD. So what happened is that when you use SSD, it is faster. But when you use HDD hard disk, it's going to take longer time. Right? Because the, you know, the writing and reading speed on HDD is different. Right? Your solid state deep in the SSD hard disk is faster compared to HDD. So you know, the idea is that the computer designer, they try hard so that you guys go less on accessing your hard disk. So that's why, you know, by having bigger RAM, right, will make the processes faster. right? And also by having the bigger cache, right? So the cache is the memory that sit inside the processor, will also make the processor faster, right? So this is just the idea I'm throwing to you guys, so that later you guys can go and have more reading on this, right? So guys, lecture it just the lecture and lab, it's not enough to to make you fully understand in this subject matter, right? So I'm developing your interest so that you can go ahead and try to do the reading by yourself, so that you can develop your interest and increase your knowledge in this field. All right, okay, compiling my code right now. Okay, getting some error. Share my screen now. All right, can you guys see my screen now?
Yes.
All right, so it's compiling. All right, so what we are doing right now, so there are two things, right, in this lab, right? So if you guys look into lab 3, right, so there are two components that we are developing for this lab. The first one is the ALU, right? So ALU stands for Arithmetic Logic Unit. So in all of the processor, we need to have an ALU, right? So this is the part where they do all those, mathematical calculation, which is very important for the computer, right? So right now, today, we're going to emulate how the ALU functioning, right? And then the second thing that we have is a counter. So counter is just a normal counter. They're gonna count from zero and until the number that we have set, right? So for an example here, this is a 4-bit counter. All right, so now let's go into this what do you call it, ALU first, right? Okay, now I'm done compiling my code, right? So I'm gonna simulate it, right? Simulate to check how my code works. Is it working as the one that I've intended? So let's do this part first. Okay, if you see here, all right, so there are two part here. So the input A, input B, and then there are ALU control, right? So how we want to understand this? Let's go and look into the code. If we look into the code, so we have two inputs, which is input A and then input B. So our input A, the size is 16-bit, and then our input B, the size is also 16-bit. Right, then we have 3 bits here, 0 to 2, which means we have 3 bits, 0, 1, 2, yeah, for the ALU control. So ALU control, we choose what operation that we want to do, right? So in this case, we have 3 operation here, right? So we have 3 operation add, operation minus, this is the AND operation, and this is OR operation. This is the logical, right? This is a logical operation. All right, so what we're gonna do here, all right, so let's just set the value, right? So value, arbitrary value. Okay, let's say we want to set a value here. Let's say we want to set 2, right? Then here also we set a value, arbitrary value x. Let's say we set a value 1. Right, okay, now ALU control. So we want to check how many operations. 1, 2, 3, 4, and then let's see 5 what happened here, right? At bit 1000. So let's highlight value, arbitrary 0. Oh, sorry, the 0 there. Right, okay, then here you set 001. Let me just if you guys realize in this code we don't have any clock, right? So it depends when you need a clock. It's not all the time that you need to have a clock. But normally most of the component in the processor you need to have a clock. So 001, 010, 011. Then goes on 0, 1, 0, 0. Right. Okay, now we have 1, 2, 3, 4. Right. Okay, now let's do the simulation. Functional simulation. All right. Okay. Now let's look into the result. Right. Okay. Now let's set the result into hexadecimal first. All right. For the first operation 0, 0, 0. Let's go and check the code. Right. So code. So operation 0, 0, 0. The operation is plus. All right. Okay. Let's check when it is 0, 0, 0. 2 plus 1 equal to this one. Oops. Okay, 2 plus 1 equal to 3, right? Then the second one, right? The second one is operation minus 2 minus 1 equal to 1. All right, okay. But then here, why we are getting 0? Right? Because this is not multiply. This is logical AND. Okay, how we can understand logical AND? Right? So you have to change the radix into binary. This one also change it into binary. And then, okay, we see here what we got here. Okay, let's change the results into binary. All right, okay, wait, now can I see the value? Okay, all right. This one is one. Okay, this is the second operation, right? So 0, 1, 0. So 0, 1, 0 is AND operation. What happened is that, so we're going to end by bit, right? Okay, 0 logical AND with 1, right? Then what we got is 0. 1 logical AND with 0, then you also got 0. That's why the result is 0, 0. Right? And then when it is 0, 1, 1, what happens is that you OR it, right? So A and with B. A OR with B. So at this operation here, what happens is that you OR it. So 0, you OR with 1, you get 1. 1, you OR it with 0, then you also got 1. So that is logical OR. And then for 1, 0, 0 is getting 0, 0 output. Why is that happening? Okay, begin if. Right? If A is lesser than B, right, then output 1. If not, then output 0. So our A value is equal to 2 and our B is equal to 1. So in this case, this condition does not meet because our A is greater than B. That's why we are getting 0. But if you change the value, if A is greater than B, then you're going to check the output, you will get 1, right? So that is how it is. Right, so in this part, assign 0, right? So this is your 0 bit, right? So 0, and then it's depending on the result, right? So if all the result is equal to 0, then the 0 bit will be 1. Else, the 0 bit will be 0. So that's why when you look into here, when all the output is 0, then the 0 bit will be high. But when the output result is not 0, all 0, then the 0 bit will be low. Again, you see here, when all the output result is 0, then the 0 bit again turning into high. All right, that's all for ALU. Any question, guys, for the ALU?
Sir, can scroll to the front part.
Right, fine. Okay.
Okay. Oh, okay. I just want to check the front part only because I seen just now because it's 2 plus 1 is equals to 3, right? Here
Yeah.
the operation. But the front here we got the 0 here. I didn't see.
Okay. All right. Any question, guys? This is pretty simple, but I think the most important thing is the understanding. All right. Okay. So I'm just going to show this part. Okay. But for the second part, you guys can go ahead and try it for this 4-bit counter. But I'll explain how it works. Right. So again, you have a module. You name it as a counter. So these are all the input output pins that you have. Count, enable. Okay, guys. You see here. This is a different way of doing it compared to our lab 2, right? So in lab 2, within the module declaration, we already declare which one is the input, which one is the output. But here, what we did is that we just declare the name, right? So we have count, enable, clock, reset, without knowing that it is input or output here, inside this bracket here. And then we declare it outside there. So enable, clock, reset, and is input, which is 1 bit. And then the count is output, and the type of the output is register. All right, so the type of register, this is the type, like there are 2 types, right? It's a register and also it can be wire. For the register, it will store the value, right? So every time you change, example, right? So what are the difference between register and also wire, right? Okay, let's see. So for a register, right? For a register, so let's say this is your clock, right? If it is a register, right? So let's say register A, you name it as A, right? And it is 1 bit. And you give value here, you give value 1 here, right? So you give value 1. So okay, this is your input. So this is your input, right? This is your input. Sorry, this is register just can be output, right? So your input A, right? So let's say this is your output, and then you give the name, type is register, right? Register, and then let's say B, and then B, okay, within the code you assign, right? So so this is B. So B is depending on A value, right? Okay, this is how you do it within the code. Okay, what happened is that when the clock cycle, sorry, let's extend it a bit, right? Okay, when the clock cycle is high, it's going to trigger the output. Right, when you set it as a register, although it's already low here, the output will remain high. But if you change it as a wire, whenever this is low, right, I mean the next clock cycle, sorry. Okay, for register, when this is high, right, so it's remain high up until the second positive edge of the clock cycle, right? But for wire, whenever it's going to follow exactly as the input. So whenever you set the input is high, it's going to be high, but when you set it's low, and it's going to turn into low, like that, right? There's a wire. There's a difference between wire and also register. That means, the register will store the value until you change the value. I'm not sure this is confusing for you guys or not, but it's okay. Later when we come into example, I'm going to try to explain it again. All right. Okay. Now let's focus on this code first. All right. Can you guys see my screen? You guys still can see my screen, right?
Yes.
Okay.
Yes, sir.
All right. So okay, this is our module counter. Right. So we have output register. So we have 4 bits output, 0 until 3, 0, 1, 2, and 3. Okay, then always, every time at the positive age clock or negative age reset end. Okay, you see here, right? So this coding down here, right? This within the always block, right? So it's going to be sensitive of the positive age of the clock or the negative age of reset end signal, right? So if okay, reset end. Okay, what is the symbol here? So this symbol here means not, right? So if reset end means that, let's say you set your reset end value here equal to 1, right? So it 1 and then you not it, it becomes 0, right? So but if you set it as 0, then it's become 1, right? So what happened is that if the value inside here is 1, right, then counter is equal to 0, right? Else enable. Okay, then if this is not the reset end, if not it's not 0, then the counter will activate means that it will start to do the counting. It start to count from 1 until the this one until the maximum number of 4 bit, right? So 4 bit you can get until what number? 16. Yeah, it's a until 15, right? 0 until 15. So that's maximum number you can get. So you can see if you let it count, so you just let the counter on, it's gonna repeat, right? 0 until 15, and then it goes 0 and 15 again, right? Then end module. So there's a 4-bit counter. Right, so this is the exercise that you need to do. Try to figure out how you can get the result for this task, right? Okay, I think that's all explanation for me. You guys have any question?
Sir.
Yeah.
Just now the code inside got a wave sign there. So what is the wave sign meaning here? If RST here.
This one? Wave sign, right?
Yes.
Okay, this sign means that not. Logical not.
Oh, so it's mean the RST is lower. If RST low, so the counter will equals to a 4-bit start from 0000.
Okay, what it means, Tim Hui? Okay, I think let's do it here. And, all right. Okay, so it says this symbol, right? So RST. And, all right, so the bracket here. So you know the bracket here, you know the function. The function here. So if, right? So if. So this if, you know, so for the if to function, right? So let's say if for this code to be executed, within the bracket has to be 1, right? So this within the bracket has to be 1 value. All right, so what happened? Okay, you can set your input. Okay, let's say you set your reset and equal to 1, right? You set the value here. What happened? So you not 1, what you get is that if 0, right? So when the 0 inside here, what happened is that the code will not execute this part. It will execute the else part, the bottom part. But if you set your reset n equal to 0, what happened is that your if function, right? So you set is 0, then you not it, logical not, then it becomes 1. Then it will execute this part.
Oh, okay. So for the back side here, the 4 bit 000, it means that we set all the value to 0, right?
Yes,
Okay.
because it's that reset function, right?
Oh, so for another one is counter +1. Else if there is
Yes. Yeah, this one is just counter +1.
oh, first time see this this type of this writing style.
Yeah.
Okay, understand.
Yeah,
Thank
there are many ways of coding very loud. As long the idea is that you want the circuit to work as the one that you intended. Yeah, that's all. That's the difference between programming software and programming the hardware, right?
Okay, understand. Thank you, sir.
All right. Any other question, guys, before you guys can start working on your lab? I'll try to debug the problem with Ahmad Mahfuz. All right. So if you guys have no question, go ahead and you guys can try to work on your lab and then see if you guys have any problem. Just let me know. I'll be here until 10. Right. Right. Okay. Go ahead, Mahfuz.
Yes, sir.
Can you share your screen? Let's try to fix your problem.
Can you see my screen, sir?
Yeah.
So what should I do?
Let's look into your output waveform. The time is from 0 picosecond to 4.08 watt.
Yes.
Yeah, what the unit there I cannot see. Is it picosecond or nanosecond?
Nanosecond.
Nanosecond.
Yes.
Try to open your simulation window, previous simulation window. We just go up until wait. Go check the simulation setting.
Is it problem from the Quartz itself? I have to download again, or I didn't try this. To delete and download again.
Wait. Go to edit.
Edit. Okay.
Try to open grid size. Just want to check grid size.
Okay, it's 10.
Then okay, close it. Try to check your set end time.
What is it, sir?
Go to edit.
Okay.
Set end time.
It's 1.
1 microsecond. Alright, it's okay. Close it. You are running functional simulation, right?
Yes.
Go to simulation, go to options. Let's see what's your options.
I tried the second one, but it doesn't work.
Second one doesn't work.
Yes.
Okay, alright. Okay, now let's look at your output. The output waveform.
Okay. This one. There's something here, but I don't know how to.
Let's go and look into your coding, Mahfuz.
Okay, sir.
Okay, should be no problem. Okay, wait.
Okay, sir.
Okay, go open your output waveform simulation window. Go to edit and then try to check the grid size.
Okay.
And then once again, it should be okay. Yeah, I think everything is okay, but I'm not sure why you are getting this kind of output. So, have you tried to recompile?
Yes, right. Yes, but same.
But still the same.
Same as.
Alright, so what you can do is
I'm
that
gonna try uninstall and then install
yeah,
again.
yeah, go ahead, try that one, right? See whether that fix your problem.
Okay, now or the next class? I don't know.
Yeah, go ahead now. Of course, you still have time. Don't wait until next week, right? Wasting your time. It's already week 3, right? You guys have to be ready to start your mini project.
Okay, okay, sir. I will now.
Right, go ahead. Who else tadi yang got the problem? Ahmad Nazrin. Mahfuz, you can mute your mic.
So also got problem.
What problem? Silakan.
The waveform cannot compile.
Waveform cannot compile. Can you share your screen?
Okay. Window. You see?
Yep.
Then it's not come up.
If you click it, try to click it. Nothing coming out, right?
What?
What about the simulation you are using? Go to simulation. You are using Quartus or Model Sim 1?
Quartus 2.
Try the Model Sim 1. Good.
Quartus.
Yeah, I mean like simulation waveform editor. I cannot see your screen.
Oh.
Okay, yeah, now I can see it. Go to simulation.
Simulation. This one, you mean?
I'm not sure. I cannot see your any changes on your screen.
What should I do?
Okay, there are two options, right? I mean, model sim and quarters. The options. So, which one? Have you tried both model sim and also quarters?
Yeah, I download both.
No. I mean, like open your simulation window,
What do you mean by simulation window?
the one that you can see the waveform.
This one? Can you see it?
I cannot see. I just can see your web browser.
Okay, wait. Okay. Now, this one.
Yeah. Go to simulation.
And
Options. Yeah.
then
Yeah. Click
option,
options.
right?
Yeah. Yeah. Try that one.
Still cannot.
You did install the module sim Altera?
I think I installed already, but I don't know why.
Try to reinstall it because you cannot find it.
Oh.
Right? Okay. Go ahead and try.
Alright. Okay. I will reinstall again.
Alright.
Thank you.
Okay. Ahmad Nazrin, you still have problem? Did you fix it?
Still same, sir.
What have you done? You have already tried to reinstall it?
Sebelum ni pernah lah, tapi sekarang ni tak lagi lah.
Okay, share your screen, Ahmad Nazrin.
Sekejap. Kan yang waveform kan?
Waveform.